Welcome to our guide on rail freight routes from China. For supply chain managers, the traditional options present a hard trade-off. Ocean freight is cheap, but it takes weeks to move inventory. Air freight delivers in days, but the costs eat through profit margins. Eurasian rail freight sits right in the middle. It cuts ocean transit times by up to half, at a fraction of the cost of flying. But to actually use this network, you have to stop picturing a single set of tracks. Look at this map of the Eurasian landmass. To move these massive volumes of east-west trade, logistics providers rely on a complex, overlapping web of transit corridors. Moving a container from a factory in China to a warehouse in Europe isn't a straight shot. You are routing cargo through multiple sovereign borders, each with its own customs zones, different track gauges, and local regulations. The central problem forwarders solve is balancing geography against bureaucracy. The shortest path on a map might require crossing 4 different national borders, introducing severe customs delays. Selecting a route comes down to mapping your specific origin point in China and your destination in Europe against the path of least resistance. This geographic matrix shows the primary options. Up top is the Northern Corridor, also known as the Trans-Siberian Route. It runs from China through Mongolia, Russia, Belarus, Poland, and finally into Germany. It is highly direct if your end customer is in Northern Europe. However, your cargo must clear both Russian and Belarusian customs frameworks to make the trip. This route relies on deeply established historical infrastructure built to operate through extreme winter conditions. Then there is the Middle Corridor, or New Eurasian Land Bridge. This path routes through Kazakhstan instead of Mongolia, before connecting back through Russia, Belarus, Poland, and Germany. This specific path relies on heavy cross-border infrastructure to function, like the Korgos Gateway, where containers are physically transferred between Chinese and Kazakh rail gauges. Both the northern and middle routes eventually funnel into the exact same choke point. To enter the European Union, nearly all trains must pass through the railway crossings entering Poland. These northern arteries handle the highest cargo volumes, but because they converge at the Polish border, any localized congestion there will delay your shipment, regardless of which route you started on. To avoid that bottleneck, forwarders use the Southern Corridor. This route crosses the Caspian Sea, moving through Kazakhstan, Azerbaijan, Georgia, and Turkey, completely bypassing Russia. The physical diversion keeps cargo away from northern traffic jams, but it introduces severe bureaucratic friction. You are navigating multiple distinct national borders, which means higher customs complexity at each stop. There are also highly specialized pipelines, like the China-Iran-Turkey-Europe route, explicitly built to service the Middle East and Southern European markets. On the opposite end of the spectrum is the China-Russia direct route. It drops intermediate border crossings entirely, but the cargo can only terminate in Russian cities like Moscow. These southern and specialized tracks act as tactical bypasses. They solve specific geographic problems, but force logistics teams to manage entirely different geopolitical risks and regional customs protocols. The route your cargo takes largely depends on where it actually starts its journey inside China. Take the Yiwu Europe Railway route. It originates directly from the massive manufacturing and wholesale markets in Yiwu. This hub sets up dedicated, predefined schedules that run straight into end destinations in the UK, Spain, or the Netherlands. Further inland, cities like Chongqing, Chengdu, and Xi'an act as the major gravity centers for the network. These massive inland rail hubs consolidate goods from thousands of regional Chinese factories. While it requires internal transit to get the cargo to these yards, they offer the highest frequency of departures heading toward Germany and the rest of Europe. If your supplier is located near Chengdu or Yiwu, that geography will predetermine the most cost-effective starting track for your shipment. A shorter line on the map does not guarantee your containers will arrive faster. Freight forwarders evaluate routes using this chart. Distance to the European hub is on the y-axis against customs friction on the x-axis. Normally, routes show high directness, but when a Polish bottleneck occurs, friction rapidly increases, pushing them into the delay zone. Maintaining a tight delivery schedule often means paying your forwarder a premium to actively reroute containers around these temporary backups. The rail network is constantly shifting. Operational friction at a single border crossing will instantly override the benefits of a physically shorter track. Apply a strict decision tree to manage this network. First, establish destination. Filter out northern paths for southern Europe. Next, define customs tolerances. Eliminate the northern route if avoiding Russia. Finally, plot your origin. Proximity to hubs like Yiwu determines the exact corridor. You must know the precise start and end points of your cargo to verify the route your provider suggests is the most efficient option. Balancing geographic distance against border friction strips away the map's complexity. It turns a continent-spanning railway into a highly predictable, manageable asset for your business.